Hey everyone, and welcome back to this class, the NumPy stack in Python. In machine learning, we often work with data that is multi-dimensional. So suppose we want to sample from a 2D Gaussian with mean 0 and variance 1. This is called a spherical Gaussian because each dimension is uncorrelated and independent of the other, and they all have the same variance. When we plot the data, it should be spread out in a circle. Of course, we can just use the same function we've already been using. We just need to add more dimensions. Okay, so we can verify that these points are spread out in a circular cloud using a scatter plot. So this might not show up exactly like a circle on your screen if the axes aren't at the same scale. So you might need to drag the window a little bit. All right, so now it's a circle. Now let's suppose I want an elliptical Gaussian. This is where the variance is different for each dimension. So let's suppose I want the standard deviation of the second dimension to be 5 and the mean to be 2. Then I can just scale that column of data. So r of column 1 is equal to 5 times r of column 1 plus 2. So let's do a scatter plot again to prove that it worked. Notice that it still kind of looks like a circle, but that's because matplotlib is scaling the axes so that the data is balanced in each direction. So if we actually try to scale it properly, it should look more like that. Now we can call plt.axis equal before calling show to make each axis equal size. So let's try that. Okay, so this is the data with each axis equal to the other. Now at this point you might wonder, is it possible to create ellipses that are not aligned to the axes? This would mean that we have a full covariance matrix with non-zero values in the off diagonals, and that means that the dimensions would be correlated with each other. We'll cover that in a later lecture, and it's going to make use of Scipy.